right, so for 13.4, we're going to be looking at applications. So for this section, the idea or, there we go. So for section 13.4, we're going to be looking at applications. The expectation for this section is that you guys are going to use your calculators to actually find these definite integrals. So at the top of the page here, what I have is I just have some cheats for your calculator. I know I showed you these in the other videos, but if you're using a TI-84, TI-89, here are the instructions on how to do a definite integral. If you're not, you can do the same thing using Wolfram Alpha or Desmos. So the first idea that we're going to talk about is continuous income streams. So usually when you sell a product, you sell it one at a time, which is called discrete. However, some things have continuous. So you can think of this as pumping oil, a stream of money into a slot machine before it cashes out, things like that. So the total income that you can expect if you have a continuous flow of goods is going to be the integral from 0 to k f of t dt. Okay? So, for example, let's find the total income over the next 20 years from a continuous income stream that has an annual rate of flow at time t given by f of t equals 12,000 e raised to the 0.01 t. So the total income is going to be the integral from 0 to 20 of 12,000 e to the 0.01 t dt. Now, when we evaluate this, what we are going to get is roughly $265,000 and 683. Okay, that's it. Then you're done. Not so bad, right? Now, another example is looking at the difference between the present value and the future value of something, right? So what happens is that things change over time, parts wear down, right? So, for example, a continuous income stream has an annual rate of flow at time t of f of t equals 9,000 e to the 0.12 t. What we want to do is that we want to find the present value and the future value of this income stream for the next 10 years if the money is worth 6% compounded continuously. So notice in both the present and the future formula that we're taking our function f of t, but then what we're doing is that we're multiplying it by e to the rt and e to the rk. So before we get started on this guy, it's good to know what is our r and what is our t. So here our r is a rate. So r equals 0.06. All right. And then t is just going to be our variable that we're using. Okay. K, remember, k is the length of time that we've been doing this. So if we're doing this over the next 10 years, then k is going to equal 10. So if we're looking at present value, which we'll call PV, our integral is going to go from 0 to 10, and we're going to have our original function, 9,000 times e to the 0.12 t, times, now we're going to multiply it by this guy, so that's going to be e to the negative r, which is 0.06 t dt. Again, I don't expect you guys to do this by hand. You can just use your calculators. So when you plug that into your calculator, what we are going to get is that the present value is that our present value is going to be $123,318. Now for the future value, if we look at this, we're going to have e to the rk, so that's going to be e raised to the 0.06 times k, which is 10, and then we need to multiply that times our integral 0 to 10 f of t, which again is 9,000, e to the 0.12t. And then we have to multiply that by e to the negative rt. So that's going to be e to the negative 0.06t dt. You can plug this into your calculator just like this. When you do, what you're going to get is you are going to get that this is roughly $224,700. Okay? Now, just a quick note, when you guys are entering something like this into your calculator, you might have to enter it as e caret, don't forget you need to put a parenthesis, negative 0.06t. Okay, otherwise what your calculator will do is it'll say e raised to the negative 0.06 and then it'll multiply it by t. You don't want that. Alright, the next topic is going to be consumer and producer surplus. Okay, so suppose we're selling a new computer and are considering selling it at about $1,000 to make a profit. However, what we discover is that consumers are willing to spend $1,200, so we sell it at $1,200. That means that we made $200 more than expected, or as the producer, we have a surplus. So if we had sold it at $1,000, then what would have happened? What would have happened is that instead of us having the surplus, then the consumer would have had a surplus. So when we are figuring out this formula, okay, the producer surplus, so that's our surplus that we're interested in, is going to be P1 times X1 minus 0 to X1 g of X. Now, here's the important part to remember, is that X1 P1 is going to be the equilibrium for supply and demand. So that's going to be this point right here. Okay? So what we're doing is essentially we are finding P1 minus X1, so we're finding the entire square of this equilibrium right here, and then we're subtracting, okay, what we thought we were going to make, and then that's going to give us our surplus. So just a geometric representation of that. So, for example, let's say the demand function for a certain product is P equals 280 minus 4x minus x squared, and the supply function for it is P equals 160 plus 4x plus x squared. We want to find the producer surplus at the equilibrium point. So the first thing we want to do is we want to find this equilibrium point. So remember, the equilibrium point is when our demand is equal to our supply. So we're going to set these two equals. So equilibrium point is going to be, again, when supply equals demand. So we're going to have 160 plus 4x plus x squared equals 280 minus 4x minus x squared. We're going to move everything over to one side, so that's going to give us 2x squared plus 8x minus 120 equals 0. When we factor this and solve for x, here's what we're going to get. We're going to get 2 times x minus 6 times x plus 10 equals 0. So that means we're going to have x either equals 6 or negative 10. Now, having a negative amount of items doesn't make sense in this context, so our equilibrium is going to happen when x equals 6. If we take this and plug it back in, okay, to our supply function, or I'm sorry, not our supply function, into our demand function, we're going to get 280 minus 4 times 6 minus 6 squared equals 220. So what this does is this gives us the point 6, 220, which is that x1 p1 that we need, whoops, that we need at the beginning of our function. So to find the producer's surplus, we're going to have P1 times X1, so we're going to have 220 times 6 minus the integral from 0 to x1, so from 0 to 6, times our function g of x. Now remember, our function g of x is going to be our supply function, so that's going to be 160 plus 4x plus x squared dx, which is going to give us a surplus of 216. Good. All right, so we have our very last example, which is going to be the consumer surplus. So that's going to be the flip side of what we just found. So for this one, the consumer surplus is going to be very similar, except for we're going to find the area under the demand function, okay, and then subtract that square area for the equilibrium. Okay, great. Another important thing to remember is that your revenue is going to be x times your demand, or times the amount of things that you've produced. So, for example, a monopoly has a total cost function, c of x equals 1,000 plus 120x plus 6x squared for its product, which has a demand function of p equals 360 minus 3x minus 2x squared. What we want to do is we want to find the consumer surplus at the point where the monopoly has maximum profit. So here's the first thing, is we're going to note that c of x, our cost function, is 1,000 plus 120x plus 6x squared. And then our revenue function is going to be, remember, we're going to take our profit function and we're going to multiply it by x, and that's going to tell us our revenue. So that's going to give us 360x minus 3x squared minus 2x to the third. Now, to find the maximum profit, what we need to do is that we need to find the derivative of both of these, okay, and set them equal to each other and solve. So when we do that, what we are going to have is we are going to have 120 plus 12x for our cost function's derivative, and that's going to be equal to the derivative of r of x, which is going to be 360 minus 6x minus 6x squared. Okay, move everything over to one side, so we're going to have 6x squared plus 18x minus 240 equals 0, which is going to have a 6 times x minus 5 times x plus 8 equals 0, which is going to have the solution for x equals 5. Remember, it also has the solution x equals negative 8, but we don't want that one because it's negative. So we know that we're going to hit a monopoly when we sell x equals 5, so 5 products. So what that means is that our p-value is going to be 360 minus 3 times 5 minus 2 times 5 squared. So I'm just taking that 5 and plugging it into the demand function. And that's going to give me 295. So I'm going to have the point 5, 295. So when I'm finding the consumer surplus, at the point where the monopoly has its maximum profits, I'm going to be looking at the integral from 0 to 5 of that profit function, so 360 minus 3x minus 2x squared dx, and then I have to subtract from that x times p, so that's going to be 5 times 295. And when I do that, I'm going to get the consumer profit of $204.17.